Our definition of a dead world is a planet or moon lacking significant geological, atmospheric, or biological activity that is characterized by the absence of active volcanism, tectonic processes, or atmospheric dynamics. Jupiter's moon Io was previously speculated to be such a world, pitted with impact craters. But Voyager 1 and 2 on their flyby of Jupiter in 1979 stunned scientists with the revelation that Io was a highly dynamic and geologically active world with numerous volcanic calderas, lava flows and sulfur compounds. So join me, the Cosmic Skipper, as we discover why Io is the most volcanically active place in the solar system where ice forms on its fiery surface. Volcanoes on Earth are often characterized by a conical shape with a central vent or summit crater, through which lava, ash and other materials are ejected during eruptions. Some of the largest eruptions in history have produced eruption columns that reach heights of over 25 miles. Io, with a diameter of 2,263 miles, is 29% smaller than Earth, where the height of volcanic plumes is primarily determined by the composition of its atmosphere, the nature of volcanic eruptions, and the strength of the eruptions. Notably, NASA's New Horizons spacecraft in 2007 caught a volcanic complex in Io's northern region called Tvashtar erupting with a massive plume that reached 190 miles into space. And with Io boasting over 400 active volcanoes on its surface, many of these eruptions are occurring not in conical shaped mountains but in vast volcanic calderas. These calderas form through the eruption of sulfur and silicate materials, where the gravitational interactions experienced by Io during its orbit around Jupiter indirectly but significantly contributing to the formation of these extraordinary volcanic features. Influenced massively by Jupiter's immense gravitational force, and to a lesser extent by the neighbouring moons Ganymede and Europa, Io follows an orbital resonance with the other moons. For every orbit completed by Ganymede, Europa completes 2 and Io completes 4. At specific points in its orbit, when Ganymede and Europa align on one side and Jupiter is on the other, Io undergoes intense deformation. With the moons and planets progressing on their orbits, other distinct alignments take place, which brings Jupiter and the moons together on one side, resulting in this side of Io being pulled towards them. These gravitational interactions induce tidal forces and stresses on Io, significantly shaping its geological activity, which produces the volcanic features we see and pronounced deformation the world undergoes. As a result, the surface of Io bulges by as much as 330 feet, producing significant frictional heat within Io's interior, 20 times more heat flow than that observed on Earth. This heat triggers the melting of subsurface rocks, forming concealed reservoirs of magma. With these reservoirs, a cauldron of pent-up potential energy is set in motion, creating the conditions that characterize the volcanic eruptions on Io's dynamic surface. As pressure beneath Io's crust reaches critical levels, molten material is released, resulting in spectacular volcanic activity. Some eruptions, such as those at Masubi, are explosive, propelling molten silicate rock, sulfur dioxide and other volatile materials hundreds of miles into space. Other volcanic occurrences take the form of effusive eruptions, where a gradual release of magma creates lava lakes that stretch across Io's surface, forming vast volcanic calderas or depressions. These lakes intricately connect to magma reservoirs beneath Io's surface, playing a vital role in the Moon's dynamic geological activity. One notable lake is Loki Patera, spanning an area of 125 miles and producing a heat output greater than all volcanic activity found on Earth. These eruptions involve the cyclical cooling and thickening of the freshly formed crust on the lake surface. During a period of 500 to 600 days, this crust loses its buoyancy over the molten lava beneath, sinking in the process and allowing fresh magma to flow onto the surface, where the cycle repeats. Despite the volcanic fury on Io, where temperatures reach 1200 degrees C, the Moon, positioned 484 million miles from the Sun, receives little heat energy, and so with an average surface temperature of minus 163 degrees C, a peculiar atmospheric twist occurs, the formation of ice on the Moon's surface. Arising from intense volcanic eruptions and shaped by the intricate synergy of extreme cold and Io's atmospheric composition rich in sulfur dioxide, the Moon's surface boasts white deposits reminiscent of Earth's frost. Io's 400 active volcanoes erupt, expelling plumes of volcanic materials that include sulfur dioxide into the cold expanse of its atmosphere. Condensing at a temperature of minus 73 degrees C, sulfur dioxide undergoes a transformative process, freezing into crystals. These crystals fall back to Io's colder regions, creating a blanket of white deposits across the Moon's surface. Io may be a tortured world with a fury unmatched in the solar system, with a frosty volcanic abyss of a surface. But far from the dead Moon we once thought it was, it is a remarkable environment of unparalleled harshness. Thank you so much for watching, and if you enjoyed it, please consider giving it a thumbs up and subscribing if you've not already done so, as your support is greatly appreciated.